Hi everyone, thanks for watching. This video is about Newton's second law, and our guiding question here is if an object experiences unbalanced forces, how can you find the acceleration, right? So linking the force to your acceleration. So Newton's first law was all about what happens if there are no external forces on an object, right? So if the net force is zero, remember Newton's first law was an object in motion stays in motion unless acted upon by an outside force. Newton's second law talks about what happens if there is an outside force acting on it. So the big idea is that the net force, which remember net is just the total force, is related to the acceleration by F net is equal to ma. So this means that the acceleration is proportional to the net force. And so just to drill down on what that word proportional means, it means that if the force is doubled, the acceleration also doubles too. If you triple the force, you triple the acceleration, quadruple the force, you quadruple the force, right? If you one half the force, you one half the acceleration. So it just means that whatever factor you change this variable by, you change the acceleration by the same amount. This also means the acceleration is inversely proportional to the mass. If you rearrange the equation, you can see that it is a or F net divided by m. So that means that if you put a mass in that's twice as big, that puts a factor of 2 in the denominator, and that would then one half the acceleration. So if you try to accelerate something that's twice as heavy, then it will accelerate at one half the original value. Okay, let's take a look at the class examples here. So the first one is we have a man pulling a 20 kilogram crate by a rope with a 100 Newton force. If the force of friction is 25 newtons, find the acceleration. So here's just a little drawing of a guy pulling a crate. And then, of course, your force diagram is going to look like this, where you have your normal force up and your force of gravity down. They should be equal because we do have balanced forces vertically. But this problem is more about the horizontal here. We have a 100 Newton force to the right. We have a 25 Newton force of friction to the left. And so what we can see is that, right, we have unbalanced forces. Because we have a greater force to the right than we have to the left, which means we have a net force. So if we sum our forces in the x direction, so that's going to look like this. We sum forces in the x direction. Recall that we previously would always put 0 right here because the net force on an object with balanced forces of it would be 0. However, now that it's accelerating, we're going to put ma, which is one way of expressing the net force. The other way of expressing the net force is to actually go ahead and sum the forces. So forces to the right, which would be tension, minus forces to the left, which would be friction. And so now our summation looks like this. And the reason, again, right, these are just basically two ways of expressing the net or total force. We have ma over here and T minus force of friction on this side, the sum of the forces. So really the only change for us is that instead of putting a 0 right here, you're going to put an ma. Right, we were always kind of putting ma, but like a was always 0 previously. All that's left to do now is to solve. So, right, our mass is 20 kilograms. So we'll put 20 kilograms in for M. We are looking for A. T is 100 newtons minus the force of friction, which is 25 newtons. It's going to give us 20A is equal to 75 newtons. Divide by A. And 75 divided by 20 is going to give you what, 3 point something. 3.75. And the units of acceleration are meters per second squared. So don't forget that. All right, let's take a look at example 2. So this time, right, we're going to have a vertical acceleration because you're standing in an elevator that is accelerating upward at 1.5 meters per second. What is the normal force acting on you? So if you're standing in the elevator, let's say this is your force of gravity, and then your normal force is going to be bigger than that. I maybe exaggerated that a little bit, but right, note that we have a bigger upward normal force than downward gravity force. Basically, it's just showing that we have a net force upwards so that you can accelerate upwards. So this time, because the acceleration is vertical, we're going to sum our forces in the y direction. We have ma, and then we have up forces minus down forces, just like before. Um, so now we can go ahead and plug in some of our numbers here. Let's see here, our mass is 65. Our acceleration is given at 1.5. Please make sure that, right, so this 1.5 could be positive or negative depending on the direction. So since it's a upward 1.5 and like normal force is also upward, those need to have the same sign so they're both positive. If it was a downward acceleration, I would want to put a negative 1.5 in here so that it matched the negative force of friction or force of gravity. So just make sure that you're keeping, paying attention to this, whether that number should be the acceleration should be positive or negative. We are looking for the normal force, right? So it says what is the normal force? So I'm going to leave that there. And then let's not forget that the force of gravity is really m times by g. So that would be 65 times by 9.8. So let's do this. 65 times by 1.5 is 97.5. Normal force minus 65 times by 9.8 gives you 637. Add the 637 to the other side, and you're going to get that normal force is equal to 637 plus 97.5. And you get 33.4, 734.5 newtons. So note that the normal force is bigger than the force of gravity, right? Force of gravity is 637. Normal force is 734, meaning it's bigger. All right, you'll see these problems start come back up again. They're not anything like in terms of summing forces, but they are just like getting back to the kinematics that we were doing. If you start at rest, how fast are you going after accelerating for 2 seconds? So, this is the same kind of problem we were doing, back when we were doing kinematics. So we have, let's see here, it starts at rest. So that tells us our initial velocity is 0. We want to know how fast we're going at the end. So that means we're looking for our final velocity here. We know that our acceleration is 1.5 meters per second squared. And we know that the time is 2 seconds. So as we look at that, we can figure out that we're going to want the Paul equation. So right, going back to some of these old things that we were doing. Plug in the information that you know. 1.5 times by 2 gives you 3 meters per second. There you go. All right. Well, that's all of our notes for the Newton's second law physics journal. So hopefully that helps. As always, let me know if you have any questions. Thanks for watching.